Hello friends, my name is Ritik Pathak. I am doing internship in the Spark Foundation and this is my task 2. The problem statement is to predict the optimal number of pressures from the ice dataset and represent it visually. Here I am importing the important libraries like pandas, numpy, sklearn.pressure, sklearn.metrics, matplotlib and seaborn for visualization. Here I load the dataset that is in CSV format. Here I use .head function to show the upper 4 values of the record, and here these are the lower values of the data set. Then I am doing EDA process. Here I will check the dimension of the data frame, the type of the data frame, the distribution of variables. Then I will check for the outliers, then summary statistics, then check missing values, and at last I will scale the data. Here we can see that the shape of the data is 150 by 6, which means there are 150 rows and 6 columns present in the dataset. Now checking the types of data types of the columns. There are multiple data types like integer, float, and object. Now we will drop the unwanted columns from the data, which are ID and species. Now again checking the data types of the column to ensure that the all data are in the same data type. Now distribution of variables. As all the variables are numerical, we plot the box plot for each variable to check the distribution. Also, we can use the box plots to identify the outliers in the variable. Here I use RC param and figure dot fixed size 8 by 5 to fix the size of the images of graphs. We can see that the sepal length, sepal width, petal length and petal width, all the columns have not any outliers except sepal width. There are 4 outliers in the sepal width, which will not affect the data. Now we will see the histogram of the data. We can see that the data is skewed. Now scatter plot between the sepal length and sepal width. And pair plot of the ice data set. Now we will look for the summary statistics. Here I describe the data. From that we will count mean, standard deviation, minimum value, and first quantile, second quantile and third quantile of the data, and the maximum value of the all columns. Now I am going for finding the missing value. Here we can see that there is no missing value present in the dataset. Now I I will use the Seaborn library to show the relationship between the dataset. Here we can see that the sample width has 4 outliers. We can remove it by some methods. First, we will calculate the IQ, interquartile range. For that, we will calculate first quantile and third quantile and define the threshold value. Then remove the outlier by imputation of the median. Then again check the percentiles of the isolator set: 90%, 95%, 96%, 97%, 98%, and 99%. Then we will do the feature scaling. Feature scaling we use to transform all the variables in the same range. If the variables are not in the same range, then the variable with higher values can dominate our final result. Scale the data. Here let us use the z-score normalization, which is a standardization technique, to scale the data set. In the scale data, each variable will have a mean of 0 and a standard deviation of 1. We are copying our dataset in a new variable named features. We can see that the features had upper values. Now standardize the features. We use standard scaler to scale the dataset and then fit and transform and save the fitted dataset in features scaled variable. Now we will use the dendrogram to see the clusters present in the data. Here we can see that with the line is crossing 3, that means the optimal number of clusters will be 3. Here we will fit the data in agglomerative cluster. Here we will save our clusters in ICE dataset with a new column named cluster. Here we can count the clusters. We can see that 71 values are in a cluster, 49 values in second cluster, 30 values in third cluster. We use group by method to make a group of that clusters. You can save the clusters in a CSV file format to look in Excel. Here I used k-means clustering. You can use other methods like density based, distribution based, centroid based, hierarchical based, etc. Here we fit the data in k-means. Here I used elbow method to visualize our cluster. We can see that based on the elbow method, the optimal number of clusters for the data set is 3. We can see that the WCSS value decreases rapidly as we increase the number of clusters from 1 to 3. But the rate of decrease slows down considerably as we increase the number of clusters from 3 to 4. Therefore, we might choose 3 as the optimal number of clusters based on the elbow method. We can use slotted method also. It is a better way to try multiple methods and compare their results to get a better sense of optimal number of clusters. Here again I use endogram on my scale data. Now making model for cluster visualization with 3 clusters. I fitted the scaled data, and then you can see that the upper 4 values of the data with cluster column. We use cluster centers to make center of the cluster and scatter plot also. You can see that the 3 clusters with their centroid. This is the relation between the sepal width and sepal length, and their petal width and petal length.
क्या कर रहा है भैया?